Okay, so this water container here, right, basically has been made by first of all having a huge cone and then chopping off a sort of cone at the top, right? This is what we call a frustum, okay? Don't worry about that name though, okay? This is a weird sort of shape here, okay? Where, as I said, you start off with a big cone, cut off the little cone, so you end up with this shape. And what's it say in this question here? That basically they sell these, but it says then the garden centre also sells containers that are hemispherical in shape. So this one here, okay. And it says then both types of containers hold the same volume of water when full. Find the radius of the hemispherical water containers. So we want to find the radius here, this hemispherical, okay. And of course, formula we know for a hemisphere is 2/3 pi r cubed, okay, just from the sphere formula from page 2, 4/3 pi r cubed. This is 2/3 pi r cubed, half of it. What we need to do is work out the volume of this, of course, yeah, because the volume of this is identical to the volume of that, okay, really equal. So to work out the volume of this, right, of a frustum, simple thing is you just work out the volume of the big cone, okay, and then we'll work out the volume of the cone that's been chopped off there, and we'll just take them away and that'll give us what's left. Now the cone is actually given to us in the formula sheet, 1/3 pi r squared h. So 1/3 times 3.14 times the radius. Now the radius is the base radius, okay, and if we're considering the big cone here, the base radius here is going to be at the bottom here, 45, times then the height. Now the height is 180. Okay, so work that out. We get quite a big number, 381,510 centimeter cubed. Okay, then we work out the volume of the small cone. So again, 1/3 pi times r squared. Now the radius now is if you see the cone that's been chopped off, the base of it has got a base radius of 30, so it's 30 squared, times the height. And we need to determine the height of this radius here, of this cone here that's been chopped off. And if you might want to draw it in, right? And you see then, well actually it's what's left over, isn't it? Because you've got 180, if you take away that 60, you get 120 there, okay? So we tap that in to a calculator. 1/3 times 3.14 times 30 squared times 120, and that equals to 113,040. Okay, so then we work out the volume of the shape remaining. Okay, so that's big cone, take away little cone. So 381,510. I'll take away ants because the other one was the last answer. 268,470. Okay, centimeter cube. Now it's saying that it contains the same amount of water. If it contains the same amount of water, that means the volumes are equal. Okay, so we can say then, look, the volume of the hemisphere is also now equal to 268,470. And if we use it, it's the formula for a hemisphere, 2/3 pi r cubed. And 2/3 pi r cubed is 2/3 times 3.14 times the radius cubed. So we get our calculator. So we get this, 2.093 recurrent times r cubed equals 268,470. Now what are we going to do next? Well, we take that over and divide. Okay, so 268,470 divide by ants, and we get 128,250. It's a pretty big number, isn't it? But of course, to get r now, we need to cube root that. We take the cube over and you do the opposite. You cube root. So shift cube root ants. That comes out to be, there you go, 50.4, 1 decimal place. Okay, so that is the radius there of the hemisphere.